Welcome students. In this video, we are going to learn how to find out values for trigonometric ratios for different values of angles. We'll start with how to find trigonometric ratios for angle 30 and angle 60. Let's start. On your screen, there's a triangle ABC, which is an equilateral triangle. That means all three sides have equal dimension. And what is the property of equilateral triangle in terms of angles? All three angles are also equal, hence each angle having measures 60 degrees. If we draw a perpendicular from point B to point D, what will happen? It will divide angle B into two equal parts, 30 degrees, 30 degrees. And also it will divide side AC into two equal parts. Let's assume AD length is A, so automatically DC length will become A, as BD is dividing AC into two equal parts. So total length of AC would become 2A. Now total length of AC is 2A, that means A plus A. So automatically, as this is equilateral triangle, AB length will be 2A and BC length would be 2A. And as BD is perpendicular to AC, we can apply Pythagoras theorem for triangle ABD. Hypotenuse square is equal to side 1 square plus side 2 square. Hypotenuse in this triangle is AB. So AB square is equal to side 1 is AD square, side 2 is DB plus DB square. So AB square is equal to AD square plus DB square. We have lengths for AB and AD. What is the length for AB? 2A. So we get 2A square is equal to length for AD is A. So A square plus DB square. We don't have length for DB, which we need to find out. Sending A square to left hand side, it becomes minus. So we get 2A square. 2 square is 4. So we get 4A square, and A square went to left hand side with a minus sign. So 4A square minus A square is equal to DB square. Simplifying it, 3A square is equal to DB square. Taking square root on both sides, DB is equal to root 3A. Now in triangle ABD, we have angle A 60 degrees, angle B 30 degrees, angle D 90 degrees. Length AB 2A, length AD A, length BD we have found out square root of 3A. We have all the three sides of right angle triangle, and we have angles also 30, 60, 90. So we can apply trigonometric ratios to this triangle ABD. If you don't know about trigonometric ratios, first watch our videos on trigonometric ratios. Learn basics about how to find out the trigonometric ratios, and then come back and see this video. Let's find out values for angle 30, that means angle B. First is sine 30. What is sine 30? Opposite side upon hypotenuse. Opposite side of 30 degrees is AD, hypotenuse is AB. So we get AD upon AB. What is AD? AD is A. What is AB? AB is 2A. Replacing the value, we get A upon 2A. Simplifying, we get 1 upon 2. So sine 30 is 1 upon 2. We have already learned cosec 30 would be 1 upon sine 30. That means 1 upon 1 upon 2. 2 goes to numerator, so value of cosec 30 is 2. You can also find the cosec 30 value as, cosec 30 is hypotenuse upon opposite side. Hypotenuse is 2A, opposite side is A. 2A upon A, again 2. We get the same value. Cos 30. Cos 30 is adjacent side upon hypotenuse. Adjacent side of 30 degree is BD. Hypotenuse is AB. So BD upon AB. BD length is square root 3A. AB is 2A, replacing square root 3A upon 2A. Simplifying, we get square root 3 upon 2. So cos 30 is square root 3 upon 2. Sec 30 is 1 upon cos 30. So 1 upon square root 3 upon 2. Simplifying it, 2 goes to numerator, we get 2 upon square root 3. So sec 30 value is 2 upon square root 3. Tan 30 is opposite side upon adjacent side. Opposite side of 30 is AD. Adjacent side of angle 30 is BD. Length AD is A and length BD is square root 3A. Replacing this, we get A upon square root 3A. Simplifying further, we get 1 upon square root 3. So tan 30 is equal to 1 upon square root 3. Cot 30 is 1 upon tan 30. So 1 upon square root 3. Simplifying, square root 3 goes to the numerator. So we get square root 3 upon 1, nothing but square root 3. So cot 30 is square root 3. Now with same logic, can you find out the trigonometric ratios for angle A, that is 60? Pause the video here and try finding it out on your own. Don't worry, answers would be provided if you are unable. Let's find out trigonometric ratio value for angle 45. To find out, we have taken isosceles triangle ABC. Now in isosceles triangle, two sides are equal. AB is equal to CB. And that's why the angle C and angle A are also equal, which are 45 degrees. Angle B is 90 degrees. In isosceles triangle ABC, AB is equal to CB. Let's assume the length of AB as A. If AB is A, then CB or BC also would be A. So we have two sides. We need to find out the third side AC, and this is a right angle triangle. So we can apply Pythagoras theorem to find out the third side. Let's do that. So as per Pythagoras theorem, AC square, that means hypotenuse square, is equal to AB square, side 1 square, CB square, or BC square, side 2 square. So AC square is equal to AB square plus BC square. We already have AB length and BC length, which is both sides are A. So AC square is equal to A square plus A square. Adding this, we get AC square is equal to 2A square. Taking square root on both sides, we get AC is equal to square root of 2A. Now in triangle ABC, we know angle B is 90 degree, angle A is 45 degrees, angle C is 45 degrees, length AB is A, length CB is A, and length AC, which we have found out, square root 2A. Let's apply trigonometric ratios now. First is sine 45. You can take any angle, but I am taking at the moment this sine 45. That means angle A. If we take this angle, sine 45 is opposite side upon hypotenuse. Opposite side is BC, hypotenuse is AC. We have the lengths of BC and AC. BC, that is CB, is A. AC is square root 2A. A upon A is 1. Remaining is square root 2. So we have 1 upon square root 2. So sine 45 is 1 upon square root 2. Cosec 45 is 1 upon sine 45. So 1 upon square root 2. Simplifying this, square root 2 goes into the numerator. So remaining is square root 2 upon 1, nothing but square root 2. So cosec 45 is square root 2. Cos 45 is adjacent side AB upon hypotenuse AC. Adjacent side AB upon hypotenuse AC. We have AB length as A, AC length as square root 2A. Replacing, we get A upon square root 2A. Again, A gets cancelled. That means A upon A is nothing but 1. The answer is 1 upon square root 2. So cos 45 is 1 upon square root 2. Sec 45 is 1 upon cos 45. So 1 upon square root 2. Simplifying, square root 2 goes into the numerator. So we get square root 2 upon 1, nothing but square root 2. So sec 45 is square root 2. Tan 45 is opposite side upon adjacent side. Opposite side is CB, adjacent side is AB. So CB upon AB. CB length is A, AB length is also A. Hence A upon A. A divided by A is nothing but 1. Hence tan 45 is 1. Cot 45 is 1 upon tan 45. So 1 upon 1. 1 upon 1 is nothing but 1. Hence cos 45 is also 1. Let's now find out trigonometric ratios values for angle 0. We start with same isosceles triangle where one side is 90 degree and remaining two sides are 45 degree. Let's focus on this angle theta 45 degrees. Now if we start reducing this angle theta, what will happen? The height of the triangle, that means opposite side of this theta angle, will start reducing. We further reduce theta very less than 45 degrees, the height is reducing. So ultimately when theta becomes 0, we get only a horizontal line. Now if we name this right angle triangles, let's say triangle ABC, what is happening is AB has started reducing as theta is less than 45. AB is reduced further when theta is far less than 45. And when theta is equal to 0, the point A and B are at the same location. So the right angle triangle ABC looks like this horizontal line. In short, what has happened? When theta is equal to 0, AB, that was height or opposite side of angle theta, has become 0. And hypotenuse is now equal to adjacent side. In this case, AC is equal to BC. So focus on these 2 points. AB is equal to 0 and AC is equal to BC when theta is equal to 0. With this data, let's find out trigonometric ratios for angle 0. What is sine 0? Again, opposite side, nothing but AB, and hypotenuse, which is nothing but AC. Sine 0 is equal to AB upon AC. But we already know AB is equal to 0 when theta is equal to 0. So we get 0 upon AC. 0 upon anything is equal to 0. Hence, sine 0 is 0. Now cos 0 is adjacent side, that is BC upon hypotenuse, which was AC. So cos 0 is BC upon AC. But we already know AC is equal to BC when theta is equal to 0. So we can call it BC upon BC as they are same, or AC upon AC, because AC is equal to BC. So we can replace any one of the side by other side. If we divide the same side by same side, what we are going to get? 1. That's why cos 0 is equal to 1. We also know what is cosec 0. It would be 1 upon sine 0. We know sine 0 is 0. So cosec 0 is equal to 1 upon 0. But 1 upon 0, anything upon 0 is undefined or infinity. That's why cosec 0 is undefined or infinity. Similarly, sec 0 is 1 upon cos 0. We already have value for cos 0, which is 1. Replacing it, we get 1 upon 1. So sec 0 is 1. Tan 0 is opposite side upon adjacent side. Opposite side was AB and adjacent side is BC. But AB is 0, BC as it is. Hence, tan 0 is 0. Cot 0 is equal to 1 upon tan 0. That means 1 upon 0. Tan 0 value is 0. So 1 upon 0. Anything upon 0 is undefined or infinity. Hence, cot 0 is undefined or infinity. In similar way, let's try to find out trigonometric ratios value for theta as 90. Again, taking the same isosceles triangle with theta is equal to 45. Now in this case, if we increase the theta, what will happen? BC, side BC, that means base of the triangle, will start reducing. So as theta is more than 45 and start moving towards 90 degree, the BC, that means base of the right angle triangle, is reducing. So when theta is equal to 90 degree, the right angle triangle will look like a vertical line. Hence, when theta is equal to 90 degree, adjacent side, in this case BC, has become 0. And opposite side of theta, that means AB, is equal to hypotenuse. AB is equal to AC. Focus on this. BC is equal to 0 and AB is equal to AC. What is sine 90? Opposite side upon hypotenuse. Opposite side is again AB, hypotenuse is AC. Can you find out the values on your own? What I will do is I will give you a hints for all the trigonometric ratios. You try to find out values for 90 degrees for all the trigonometric ratios. Hints are cos 90 would be adjacent side BC upon AC. Cosec 90 is 1 upon sin 90. Sec 90 is 1 upon cos 90. Cot 90 is adjacent side upon opposite side. Adjacent side is BC, opposite side is AB. Tan 90 is 1 upon cot 90. You already have values for BC and AB and ACs are equal. Try to find out this on your own. Here is tabularized summary for trigonometric ratios for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Make sure you remember this, which can help you in solving the numericals.